Hey, it's Zara. In this video, we're going to be talking all about derivatives, how to compute a derivative, and what does it mean to take the derivative of a function. Differentiation is a concept in calculus that deals with how things change. More specifically, it calculates the instantaneous rate of change. And just to make sure that we're all on the same page, let's start with something more basic, like the slope of a line. The slope describes the rate of change of the vertical variable y with respect to the horizontal variable x. If I wanted to find the slope of this line, I would pick 2 points. And I would find the change in y, or delta y, as well as the change in x, or delta x. And we know that the slope is equal to the change in y over the change in x. Now, because this is a line, it has a constant rate of change. If you took any 2 points on this line, no matter how far or close apart they are, you will get the same value for the slope. That's what makes it a line. We can take this concept and apply the instantaneous rate of change of something whose rate of change is possibly constantly changing. Let's say we have 2 points on this curve here as well. We go down the x-axis, and this distance is going to get the value of x. And if we go up to this point of the function, this point is going to be x, comma, f of x. When we put the x value into the function, we get f of x, or the y value. Now, if we go a bit further on the x-axis to where the second point is, let's call this distance here h. So this second point is at the value x plus h. And we go up to the point on the graph and we say that this point is at x plus h, comma, f of x plus h. Now that we have the 2 points on our curve, we can find the slope between these 2 points. We find the slope just as we previously did using the formula y2 minus y1 over x2 minus x1. And in this case, the slope is going to be as follows. We can cancel out these x's here in the denominator to simplify a little bit, but essentially what we are doing is calculating the average rate of change between these 2 points. And you can see that if you were to pick a different point on the curve, the slope would be different because this is constantly changing. So we want this formula to define the instantaneous rate of change for any point along this curve. And we can do that by taking the limit as h approaches 0. What this means is that the distance between these 2 points, h, is going to get smaller and smaller until the distance between these 2 points is essentially 0, meaning that the 2 points are almost on top of each other. This now will give us the instantaneous rate of change instead of the average rate of change. You will often see this denoted as f prime, or even as dy over dx. Let's do a very simple example of taking a derivative using the formula we have defined. And the function we want to take the derivative of is going to be f of x is equal to x squared. And this is also the graph of this function. So using the formula for the derivative, we can substitute in the values we know. And this gives us the limit as h approaches 0 of x plus h squared minus x squared over h. We can go ahead and simplify this by expanding. We see that we can cancel out the x squareds here, and additionally we can factor out the h from each of these terms. And we can cancel out those h's as well. So remembering that this is the limit as h approaches 0, we can cancel out this h as well. And then what we're left with is just this 2x. And remember, conceptually, that the derivative is the formula for the slope of the tangent line. So if we want to find the slope for the tangent line at a specific point on the graph, say the point 2, 4, we can. Now we know that the slope is 4, and we also know that it goes through the point 2, 4. So we can write the equation for the tangent line using the point slope formula. And this is the equation for the tangent line. In my previous video on integrals, I gave the example of integrating the velocity function to get the displacement. Let's expand this notion to derivatives as well. If we are given a position or s of t, we can take the derivative and that would give us the velocity. We can take the derivative again and that would give us the acceleration. Derivatives have applications in other fields as well. In chemistry, for example, the rate of the reaction can be modeled as the derivative of the concentration with respect to time. Overall, physically, the derivative measures how a quantity changes with respect to another variable. This concept of rate of change is fundamental and appears across various scientific and engineering disciplines, providing insight into all kinds of dynamic systems.